Okay, dear friends, welcome to the online problem solving session series organized by Maths Aspirants groups. Today's session is actually a continuation of the yesterday's session. So we have Mr. Lalit, Thuwal, research scholar, IISc Bangalore with us. He will continue the discussion of previous year questions of CSIR net examination. I welcome everyone to this program. Welcome, Lalit.
Okay, so yesterday we have solved the problem from 2024 exam. So today we will also solve the selected problem from the 2024 exam. Okay, so at the end, I will send a PDF where the remaining questions solution, link of the remaining question solutions will be there. You can watch the solution, detailed solutions. Okay, so let me tell you it at the beginning. So let's start with this question. So this question is of part C from the abstract algebra, what it says. Okay, this can also be solved quickly. See what it says. Let f is a polynomial over R, product of distinct monic irreducible polynomials p1, p2, pn. Okay, so given that f is the product of distinct monic irreducible polynomials, or are these distinct monic irreducible polynomial, and it is also given that f is product of two or more than polynomials, right? So it is not a single polynomial like this even.
Lalit,
So yeah.
Did you started the screen sharing? I am not seeing the screen.
Yeah, screen is visible. I can see it on laptop. So right, student, you can see, right?
Yes.
Yeah. Okay, so all are reacting. So I think your internet may be down, I think.
Yeah, it may be. Okay.
Yeah. Okay, so f is not a single polynomial. Okay, not just a monic reducible polynomial. It is product of distinct monic reducible polynomials. So and this notation is the ideal generated by f in the ring Rx for any polynomial f. Yeah, for the given polynomial f. So which of the following statements are true? It asks about that. So first one says that this Rx over ideal generated by f is a field. And so this, I'm writing p1, p2, pn in place of f. Okay, so this is a field or not. This may maybe a field if we have only a, maybe in that case, suppose that we have only one polynomial here, right? Then it's a field because Rx is a PID, and in a PID, irreducible polynomials generate the maximal ideal. But here we have at least two monic irreducible polynomial in this product. So this is not a irreducible polynomial. This is a reducible polynomial. And in a PID, maximal ideals can only be generated by irreducible polynomials, irreducible elements, right? Yeah. So by Chinese remainder theorem, you can write it. So first of all, you will write this one like this. Okay. So this is well known. You know that. And then by Chinese remainder theorem, this comes out to be, okay, let me use the short notation. Okay, so product I goes to 1 to n Rx over pi x. So let's write it pi. Okay, so we have this by the Chinese remainder theorem, by the application of Chinese remainder theorem, right? You all know what is the Chinese remainder theorem? Okay, because these are irreducible polynomials. So there exist Q1, Q2 such that, because in a PID is a Bejoid domain, right? So these ideals are co-maximum. Okay, so they are pairwise co-maxima. So we can apply the Chinese remainder theorem, and you know that now just see the this one. Okay, Rx over, for example, say pi. So pi is a monic irreducible polynomial, so it will generate a maximal ideal. So this one is going to be a field. So let's denote the fields by fi. Okay, this comes out to be this. So yeah. And in the case of finite, direct sum and direct product are same, okay? Because in the option 3, it is asking about the direct sum. So this ring comes out to be the direct sum or direct product of fields, right? So it is clear. So first one is wrong, okay? This is never going to be a field, okay? Because at least 2 fields are there, okay? And product of 2 fields never a field, right? Because it contains 0 divisor, right? Suppose, for example, suppose that we have only 2 fields here, then 1, 0 and 0, 1 are the elements of these and their product is 0. But these are not the 0 elements, so it contains 0 divisor, so it cannot be a field. Okay, so let's see that what second one says. That Rx modulo F is a finite dimensional R vector space. Okay, so see. Now I would like to ask a question that how many of you know that what is a algebra? You know vector space, you know ring, you know group, right? There is a algebra structure also. So can you raise the hand if you know about that? Algebra structure. Right? Vector space structure is there. You must have seen that. Ring structure, you must have seen that. Do you know about the algebra? Okay, let me tell you, okay, what is the F algebra? So just for your information, okay? So suppose like this, C01 is a vector space, right? It is a ring, it is a vector space also. So it is a R algebra and vector space, vector scalar multiplication and the ring multiplication are compatible. So we also have a notion of R algebra homomorphism. This which map, I mean, there is a map, right? In the proof of Chinese remainder theorem, you see that there is a map so that this is isomorphic to this. So that map is also a F algebra homomorphism, R algebra homomorphism. You can check that, okay? So these are not only isomorphic as rings, but are also isomorphic as vector spaces, okay? So here we have direct sum of vector spaces and each Fi is a finite dimensional vector space. Okay, yeah, otherwise you can see like this. Okay, I have another way of letting you know that suppose that degree of F is n. Okay, say F is this. F is also monic, right? Yeah, because product of monic comes out to be monic. So dot dot dot, right? And this ring can be written something like this, right? Do you agree? A0 plus A1x bar means the coset, okay? A1, okay, this right, 1 bar. And dot 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 an minus 1. This is not the same AIs, okay? I mean, just replace this by B0, B1. Let me replace it. Bn minus 1, okay? Okay, this quotient ring looks like this. Do you agree? Right? Yes or no? Yeah, so here you can clearly see that this spans this set spans given ring, okay? Given ring. So this is a finite dimensional vector, given vector space. Is it clear? And one thing I want to let you know that this is also the quotient space, okay? Because the ideal is not only, I mean, ideal, this is also the vector subspace. You can verify that, okay? This ideal is a vector subspace and that is very easy to verify, right? You just need to check that it is closed under vector multiplication or not. Obviously it is closed because if you take some real number and say real number is R and you have any multiple of F, say GF, right? Then RGF is again in here, right? Because this is again a multiple of F. Okay, this is also vector subspace. Okay, so this is a quotient space. So we have a finite spanning set, hence it is a finite dimensional vector space. Okay, so and the third one is already correct. Okay, I have already told you that I have already proved it. That is the direct sum of field. Each of which is isomorphic to R or C. Let me tell you it. Okay, why? Suppose that we have this quotient and we have a monic irreducible polynomial. The degree of monic irreducible polynomial, a question for you, the degree of monic irreducible polynomial over R can be. Can you tell me? Just raise your hand if you can tell. I will name. Okay. The degree of a monic irreducible polynomial over R can be. I mean, you have to be quick. Okay. I mean, if you have to appear for the next upcoming exam, then you must have to quickly answer such kind of question. Okay. Isn't it easy? Okay, so many of you have raised the hand. Subranil, what can be the degree?
Yes, sir. 2. At most 2.
Yeah, at most 2. Either it can be 1 or 2. Okay. So, dear student, you should know this. Okay, I'm not gonna prove it here. So, it can be 2. If the degree is 1, say that the polynomial looks like this, right? Say the polynomial looks like this, x plus 2, for example. Then this is going to be isomorphic to R, right? Very easy isomorphism shows that, right? Okay. And if it is a 2-degree polynomial like this, then just attach a root of this polynomial, say alpha. Then, this is just C, because you are attaching a complex number. And once you attach a complex number to R, then you get the comp C, right? Because when an alpha will span this one, C. Okay. I mean to say every complex number can be written something like this. A plus B alpha. Because 1 and alpha are always linearly independent over R. Right? Yes or no? Yeah. So if the degree is 2, then the field is C. If the degree is 1, then the field is R. Okay. So this one is totally true. Okay. And there are no non-zero u's such that u to the power m equal to 0 for some n. And let me leave it as an exercise because I have already done everything. Why? How can you prove that? Let me tell you that. See, now you have this, right? You just think about it, that you have a ring which is the product of fields. Simply. Now pick any element of it and assume that this is a nilpotent. Then you will get that element is 0. Okay. Okay. So I think you can do all that, right? And if you want to learn something very interesting about this question and a lot of things, right? I mean, I have solved this question using nil radical and correspondence theorem and all, because I have time at that time, right? Because I can't spend too much time on this, but this is a very good question. So just check the solution playlist. Okay, I will share the PDF at end. You can check the solution playlist. The link will be attached there. Okay, the solution playlist of 2024. Just check there, the complete solution. Okay. So let's do it. So I will also leave something exercise in this question. Okay. So, okay, let me tell you something very interesting for this question. Okay. So can you try this question once? I mean, which one is correct? Read it and let me know if you are able to solve. Okay, then I will let you know something interesting, very interesting. Then, I mean, a trick that would be very useful in your exam, and that helps a lot of time. Okay, sometimes, I mean, using that, you can very quickly solve questions.
Sorry, sir, I forgot about holomorphic function.
Oh, actually, holomorphic functions. So, holomorphic functions are functions which satisfy Cauchy-Riemann equations and their partial derivatives are continuous, or you can say that they have power series expansion at every point of the complex number. So they are just, differentiable everywhere in the D. I mean, a differentiable function on D. Just think that as a differentiable function on the open unit disk. Okay. Holomorphic. Oh, you might be confused with the name. Okay. This means analytic functions.
Okay, sir.
Okay, so I think I should let you know. Okay. See, let D be the open unit disk and F be a holomorphic function on D such that the function gz is bounded. You have given that this function is bounded and F is holomorphic on the open unit disk. So this has a, if this is bounded, then at least you can tell me something. What happens?
It has removable singularity at.
Okay. It has. Now you can solve it further. Okay. Removable singularity at, but let me solve it partially. Singularity at 0. Now remove the singularity and solve it and get the correct answer. But see, if I am in the exam, then I'm gonna, take it without thinking. I mean, I will take it, but not solve that what is F0 really. Why? Let me tell you. See, the third option is incorrect, right? Because it says that there exists a non-zero constant C such that Fz must be this. But this has a, essential singularity. Essential singularity at z equal to 0. Yes or no? If C is non-zero, it means this cannot be true because our F is holomorphic function. And similarly, this is not true. Easy to eliminate, right? Because this function also again has a essential singularity at z equal to 0, right? Because you can just expand. I mean, if you don't know how to know, I mean, how do we know that? Expand it e to the power minus z. Okay, write the power series, then you will see that we have infinitely many terms in the principal part. Okay, that tells you that it has a essential singularity. So this is not true. Now see, if this is wrong, then first one is comes out to be true, right? We will take it. And if this is correct, then also first one is correct, because if fz is always 0, then f0 is 0. But if 2 is wrong, then we have remained with only one option, then 1 is true. Do you understand what I said? So you don't need to solve the option 1, okay? I mean, this type of things are very helpful in the exam, okay? But you should solve it quickly. So I have given it, no, you should solve it at home. I have given it given here a hint. So conclude that fz is 0, okay? Or not. So let me leave it as an exercise. So solve it. So you can use the Riemann removable singularity, okay? So what do you think? Fz is always 0 or not? Anyone?
Yes, FZ is 0.
Why? Okay, so don't tell. Okay, okay, let's solve others also. Okay, so I mean, let others solve. Okay, by this hint. Okay, so Now the question number 88. What it says, consider the polynomial fx equal to this, fx to 2025 minus 1 over f5, where f5 is the field with 5 elements. Let S be the set of all roots of f in an algebraic closure of the field f5. Which one of the following is true? Okay, so S is the collection of roots of in the algebraic closure of f5 such that alpha to the power 2025 equal to 1, right? So it says that f is a cyclic group first, and the second says that f has so many elements, okay, and the third one says that so many generators, and the last one says that S has 81 elements. So all we need to know first that how many elements S has, okay, then we will think about other options. So see, here you have to observe something, okay, that 2025 can be written, what you can write 3 square. What is the factorization of 2025? 45 का square, okay, right? Is it correct? No, 9 square, 5 square, right? So it is 81. Is it correct? Okay, so but here only crucial part in this question is this, that you can write this as this. Okay, you must have seen such kind of exercise in your books, that if you have a field of characteristic P, then this is true, right? The second one is proved by the use of induction, and the first one is directly proved. Okay, just using the binomial, and you prove that PCR is divisible by P, and that is very easy to prove. Okay, because you know the characteristic is 5. If you will expand, I mean expand this using binomial, then all the intermediary terms, I mean the terms here will vanish because 5 is equal to 0. Okay, yeah, this thing is the crucial, and everything is easy now. So now this polynomial is separable. Okay, it has distinct roots in the algebraic closure. Why? Because if you take the derivative, then see GCD is 1, right? It has all the roots of this are 0, but not any root of this polynomial is 0. No root of this polynomial is 0, right? Because if you put 0, then you get -1. If it has a multiple root, then it must be a root of its derivative also, right? So derivative, and it has no common root. It means that this polynomial has distinct roots. Okay, is separable. Separable means all of its roots are distinct. Has distinct roots. We write it. Distinct roots in F5 closure. Okay, so now S is equal to this, right? Alpha belongs to F5. X81 equal to 1. I mean alpha to the power 81 equal to 1. Do you understand this? Is it okay? Yeah. So now can you tell me what is the cardinality of C? Or x to the power 81 minus 1 has distinct roots, and algebraic closure contains all the roots of a polynomial over F5. So how many, what is the cardinality of S? Let me know. What is the cardinality of S?
81.
81, Sabas. So the cardinality of S is 81. Now, see, this is a subgroup of, sorry, this is a subset of F5 closure, and this is a finite subset, right? So I need to prove that this is a, I need to know that this is a cyclic group or not. So this is obviously a cyclic group, okay? Okay, let me prove it. First, let me prove it that this is closed, okay? Then it is very clear, right? Because field is commutative. If you take the product and you get this, it means the alpha beta is also in S. Okay. if alpha and beta in S, then the product is also in S, right? And it is enough to prove that it is closed with respect to multiplication, right? This is a subgroup test. Whenever you have a finite subset and empty, non-empty subset, and you prove that this is closed with respect to the composition, then it is a group. You don't need to check that whether or not it is closed with respect to inverses. That automatically happens. Do you know about that? In the case of finite subset, you only need to check the closeness. No need to check about the inverse closeness. Yeah, okay. So this is a subgroup. And one more result is there that if you have a field, any field, then any finite subgroup of this field is comes out to be cyclic. This is a very well-known result of field theory, right? Any finite subgroup, I mean F star, okay? Sorry. So if your F is a field, then F star is a multiplicative group, and any finite subgroup of F star is cyclic. Okay, so this is a cyclic group. It means the first one is true, and S has 5 20 25 elements. No, this is not true because 5 20 25 is not 81, right? It would be more, right? So SH 5 20 25 generators. These are too many, right? So S has exactly 81 elements. So how many generators S has, by the way? Raise your hand if you know that. Raise the hand. It will give me a sense that you are following. Okay. So you know, right, the number of generators in the S, because now you know that S is a cyclic group of order 81. So you must answer this question. Okay. You will be appearing for the NET exam in upcoming days. So you should know that. Okay. So what will be the number of generators? Okay. So far, 11 students raised the hand. Very good. So Avinash, what is the answer?
It will be 5 of 81.
Okay, good. So let's solve this linear algebra problem, okay? So first you try to solve it, okay? Suppose you see this in exam, how you solve it, and see that how quickly you do it, okay? Check your timing. I mean, the most timing you have is 2 minutes, okay? I mean, you cannot use more than 2 minutes. You just have to raise your hand, okay? If you have solved it. Don't tell the answer. Okay. Avilipsa, what is the answer?
2 and 3.
Okay. 2 and 3. Yeah. Okay, fine. Good. So see how you solve it quickly. Okay. See, you have given two matrices. Okay. First, you have to observe this thing, that this is a block diagonal matrix. Okay. Once you know the eigenvalues of A, then you know the eigenvalues of B, because one is the eigenvalue and other eigenvalues of B are just the eigenvalues of A. Okay. So once you know the eigenvalues, you know the minimal polynomial, and you know that where the eigenvalues lie, and you can quickly take, quickly know the answer. Okay, and get the solution. How? So what are the eigenvalues of A? Okay, so you have to think like that. This is a permutation matrix, right? And every permutation in, okay, and this is a permutation matrix and generated by, can you tell me? 1 goes to 2. So to which permutation this corresponds? 1 goes to 2 and 2 goes to 3, right? So this permutation satisfy sigma cube equal to 1. It means your A is going to satisfy this. So your minimal polynomial of A will divide this polynomial, right? So this polynomial has the factorization x minus 1, x square plus x plus 1. The factorization is correct or not? Correct? Okay. So now the minimal polynomial has, see, 1 is one of the eigenvalue, right? From here you can observe it. 1 is one of the eigenvalue. Yes or no? Right. And not only 1 can be the eigenvalue. I mean to say that x minus 1 cannot be the minimal polynomial. Otherwise, it will imply that A equal to I. But A is not equal to I. It means this factor also should be in the minimal polynomial. But this will come out as it is. Okay. So the minimal polynomial is this. Right? You may ask me that why the minimal polynomial cannot only this be, because 1 is not the root of this, and every eigenvalue of the minimal polynomial is a root of the minimal polynomial. Every eigenvalue is a root of minimal polynomial, right? So minimal polynomial or characteristic polynomial of A is this. Do you understand this? I mean, there are many other ways, okay? You can know the eigenvalues of A. But for this, you don't need to, draw all these. I mean, you don't need to use your pen. You can just think that A is generated by a 3 cycle. So A will satisfy the minimal polynomial of A will satisfy all the eigenvalues of A will be the cube root of unity. The eigenvalues of A can be 1 omega omega square. And this is the only possibility, because 1 is one of the eigenvalue. Not all eigenvalues can be 1. Okay, if omega is an eigenvalue, then omega square must be an eigenvalue, because complex eigenvalues comes in pair, right? So one knows quickly that the eigenvalues of A is 1 omega omega square. So here we know that eigenvalues of A is 1 omega omega square, and eigenvalues of B is 1 omega omega square. Minimal polynomial of B is, I think you must know that when you have a block diagonal matrix, then the minimal polynomial is calculated as the LCM of the minimal polynomial of all those block diagonal matrices. So minimal polynomial comes out to be this, right? They have same minimal polynomial. Any doubt? No doubt, right? Okay. Yeah. In the exam, you have to solve the questions very quickly. Okay. So sometimes you know the solution, but you don't have a smart and quick way to solve the solve the question. It might possible that you somehow scored 110 and you get a rank of around, say, 100, but you could do better with smart answers and smart strategy, okay, and a smart way of approaching the problem, okay, because there are too many ways to approach the problem, okay. And the CSIR net exam is on, I mean, this is an exam where the quickness and the smartness and a very good strategy to attempt the exam is very, very helpful, okay. This helps you to score very well, okay. Once you score around 150, then you get a rank from in between 1 to 10, and you get a chance for the interview in very good research institutes, okay. And the research institutes calls only those candidates which has very good rank in the CSIR net exam, say 1 to 25, okay. So now you can very quickly tell, I mean, now you can conclude, right, that A and B both are diagonalizable over R, obviously, because the minimal polynomial has no repeated roots. And there is a theorem that a matrix is diagonalizable over F if and only if its minimal polynomial has no repeated roots. Here we can see that the minimal polynomial has no repeated roots. Oh, sorry. It says that diagonalizable over R, but the eigenvalues are not in R, so it cannot be diagonalizable over R, but it is diagonalizable over C. A is diagonalizable over C, but not over R. It is correct. Neither A and nor B is diagonalizable over R. This is correct. But both A and B are diagonalizable over C. This is also correct. Neither A and nor B is diagonalizable over R. C. This is incorrect. So please ask if you have some question, if you couldn't understand something, anything. Is everything clear? Do not hesitate to ask me, okay? Okay, so I assume that everything is clear. Okay, so I mean, can you tell me the eigenvalues of A and B? Yeah, please.
Sir, in this one, we have no, if eigenvalues are distinct, then it is diagonalizable. But for the B,
yeah. Eigenvalues are distinct, then the matrix is diagonalizable, yes.
But for the B matrix, the eigenvalues are 1, 1, omega, omega square, no?
Yeah. So, but the converse is not true. Eigenvalues are distinct, then the matrix is diagonalizable over the field where the eigenvalues lies. But if the matrix is diagonalizable, then there is no need that the eigenvalues should be distinct. For example, you can take this matrix, identity matrix, all its eigenvalues are 1, 1, 1, but it is already diagonalizable. No need to do anything, right? It is a diagonal matrix.
Okay, sir.
Yeah. So yeah, what are the eigenvalues of A and B? The eigenvalues of A are, okay, I will not solve this question, okay? I have put it here just for you, that you will solve and let me know the answer. So eigenvalues of A is 1, 3, and eigenvalues of B is -1, 5. So can you tell me the eigenvectors of A? Eigenvectors of A is 1, 0, and what is the other eigenvector? And the eigenvector of B is 0, 1, and what is the other eigenvector? Can you tell me?
So for A, 1, 1 is also the one eigenvector.
1, 1 is the eigenvector for A? I don't think so. No, 1, 1 cannot be eigenvector, I think. It will not definitely, because if 1, 1 is eigenvector, then each row, yeah, definitely it is. Sorry. It is eigenvector. Thank you. 1, 1 is an eigenvector because each row sum is 3. Okay, so yeah. So what is the eigenvector of B? Let me know. Is it distinct from all these, right? It is neither 1, 0 or not 1, 1. Yes or no? Because these are not the eigenvector. This is not an eigenvector of B, and this is also not an eigenvector of B, right? So take all these product. denote them by V1, V2 and U1, U2. Okay, so U1, U2. So how many are these? So V1, U2 and V2, V2. Are these four? Are these four or not? So how do you say that these are four? Actually, this is not a well-defined multiplication. How can you multiply two column vectors? Are you listening everything? Not following? Can you multiply two column vectors? How do you multiply that?
Sir, one vector is a transpose.
Well, yeah. Okay, I will take the transpose. Right. Good. So, okay. So now this is a matrix of 2 cross 2. This is a matrix of 2 cross 2. This is a matrix of 2 cross 2. This is a matrix of 2 cross 2, right? So now see. T, for example, VU transpose, okay? What comes out to be? It comes out to be AV U transpose into V transpose, right? This comes out to be AV into, let me know what this comes out to be, VU transpose, right? But AV is eigenvalue, say, let's assume that this is the eigenvalue 1, lambda 1. Just say that lambda 1, okay? Then, and another eigenvalue, VU is the eigenvalue of this. So lambda 1, mu 1. So the eigenvalues of, oh, yeah, lambda 1 V. This will be lambda V and another will be mu V. Lambda mu U. Okay. So it means lambda mu is an eigenvalue of, oh no, I mean, this is not working, right?
Sir, transpose.
Will this be transpose? No, yeah, this will be transpose. Thank you. So transpose. So what does it mean? It means that this is an eigenvector, right? Because this is a matrix and this is an eigenvalue. So what are the eigenvalues of your T? Let me know. I'm letting you know quick way, okay, to solve this problem. This problem can also be solved just by finding the matrix of T and you see that trace and a determinant, okay? But I'm not going to let you know that way. I want to let you know something quick, okay? This is quick, this is not difficult, right? Let me know the eigenvalues of T then.
Sir, all possible multiples are.
All possible multiples. So what are the all possible multiples?
सर जो आइगन वैल्यू हमने निकाली है सर ए एंड बी की, उनके पॉसिबल मल्टीपल निकालेंगे। इसके जैसे लैम्डा 1 इसकी कितनी है आइगन वैल्यू 1 एंड 3 है, दूसरे की -1 5 है, तो उनको पॉसिबल
तो क्या
एक दूसरे से
आएंगे
मल्टीपल निकाल।
ठीक है, तो आइगन वैल्यू क्या आएंगी बताओ। तो इट्स योर वर्क टू कैलकुलेट नाउ।
सर -1 और 5 और -3 और
-1 और 5 और -3 और क्या
15.
So now can you conclude which one is correct or which one is false? You should do it, right? So let me know the answers now.
1 and 3.
1 and 3. Okay. So in this way also you can solve this question also, okay? No need to find the matrix. But if you don't know this way, you must find the matrix, but very quickly, okay? And there is no possibility of miscalculation here. See, in the matrix you might miss something and make some miscalculation, and this is also important that how you are solving the questions, okay? Suppose that you are finding the matrix and you make one entry wrong, then everything is going to be wrong, okay? But here is no possibility of being wrong, okay? But you should know the way. Okay, if you don't know the way, then you would not be able to solve. I mean, you will be able to solve, but there may be some miscalculations and all. Okay, so I'm not saying that you should solve like this. I'm only letting you know that this way saves you from the miscalculations. Okay, and be careful for the miscalculations in the exam. Yeah. Okay, so let's solve this. So how do you solve this? Can you try? Let me give you 2 minutes, okay? So let me read the question. FC to C be the function defined by fz equal to this. E to the power cos 1 plus I sin z. Okay. So it says that fz is u plus iv, then del u by del x at 0, 0. So can you solve it? Okay, I will not say that you solve it. I'll just let you know. I mean, I will directly let you know the answer. So see, many of you will go like this. First, you will find the real and imaginary part. Once you know the imaginary part, then you will calculate like this, right? Del u limit k tends to 0, u x plus h 0, something like that, and make the calculation. But you should not do this, okay? This may be lengthy, and I don't know. I have not solved in this way, but this may be lengthy. Okay, so see, if fz is this, then in the proof of Cauchy-Riemann equations, you must have learned about this, right? Ux plus ivx. That derivative of f is this. So if you want to know the real part, I mean ux at 0, 0, just put z equal to 0. Then this means that you need to find the real, what is the real part of f dash 0. Okay, and f dash 0 is easy to find. How do you find the f dash 0? You have given fz. So can you find f dash z? To find f dash z, what you need to do, that just differentiate the given function. Okay, this comes out to be this, and once you differentiate this, then cos 1 plus I is a constant. So what do you get here? Cos 1 plus I, right? And if you differentiate sin z, then what is the differentiation of sin z? Cos z, right? Yes or no? And now don't try to write f dash z as a real and imaginary part, because you don't need this. First put z equal to 0, okay? Because that way would also be length. First you need to find what is f dash 0. Once you put z equal to 0, what do you get? Here you get e to the power 0, here you get cos 1 plus I, and here you get cos 0, and cos 0, it means cos 1 plus I. Now separate it as a real in the, now find the real and imaginary part of it. So what is cos 1 plus I? Cos 1. Okay, then what is the formula? Cos iy, right? It means cos I plus minus or plus I don't need this, right? Because this is the imaginary part or real part. This might be real, just check it. So sin x, sin 1, sin I, right? So cos 1. Okay, let's see the answer. Okay, also, I mean, how, okay, cos 1 should be there. Cos I means,
Sir, cos hyperbolic.
okay, cos hyperbolic y. So, and I
Sir,
sin 1,
होगा sir.
cos hyperbolic
Sir,
1.
1 होगा.
ओके, आई साइन, ओ यहाँ आई नहीं आएगा ना, वो आई, ठीक है. ओवरऑल ये वाला इमेजिनरी पार्ट, दिस इज द इमेजिनरी पार्ट. आई मीन आई विल बी देयर बट लेटर. यहाँ पे आई नहीं आएगा, मैंने 2 बार आई लिख दिया ना, साइन आई भी लिखा है. ओके, so I mean later I will come, but we don't need this part. Okay, this is imaginary part. I mean we are done. Actually our answer is this. So cos 1 So our answer is this. ux00 is the real part of f dash 0. That is cos 1 cos hyperbolic 1. Okay. Yes or no? Cos 1 means this, and by 2 hyperbolic means this. Right? Is it clear to everyone? I will not consider this one, right? Because it's the imaginary part. Sin I means sin hyperbolic 1. Okay. So it means the correct answer is this one. Okay. Is it clear? Okay. Okay. So now you will do this question. Okay. So let me see that we have already solved a diagonalizability question before. So can you solve this? Try to solve this. Then I will let you know. Okay, how to solve this question in the exam. Raise your hand once you done. Sayan, which one is correct?
Hello.
Yeah. Which one is correct?
सर पहला वाला इनकरेक्ट है, दूसरा वाला भी सर आखिरी वाला सही है, और मिडिल में एक मिनट सर, तो आप ट्राइगोनल है, और सर 2 और 3 गलत हुआ है सर।
तो ओवरऑल 4th करेक्ट है।
हाँ
ऐसा
सर,
आप कह रहे हैं?
हाँ।
ओके, ठीक है। रितिका, which one is correct?
The fourth one is correct.
Okay, so do other 2 students who have raised the hand think the same? If no, then you can let me know. Okay, fine. So how do we do this? Okay, see. The first option says that one A and B are upper triangular, then M is diagonalizable over R. Okay, so let's check this. Okay, so pick 2 upper triangular matrices, A, B, C, E, F, 0, G. I'm not going to take examples and all because the calculation would be easy. So I'm just taking the general matrices, okay, and taking 2 cross 2 matrices which are upper triangular and multiplying them does not take, is not a big calculation, I meant to say. Okay, so this comes out to be AE, FB, 0. So, and here we get AG plus CF, right? For the other part, I mean EG, say this one is A, this one is B, And if you calculate BA, then you get AC 0B. So you just have to replace, change the role of entries of A and B. So this comes out to be EA, BF, 0. A means E, right? EG means C. EC. And C means G. F means B. Is it correct or not? Okay. So now if you subtract C, now see, if you find the commutator, then you get this 0, 0, 0 and AG plus CF plus EC plus minus GB, right? Now see, this is a nilpotent matrix, we know, because all the eigenvalues are 0, right? Right? Now, can you choose A, B, C, and all these entries such that this comes out to be non-zero? Because if this comes out to be 0, then your matrix is not going to be diagonalizable, right? So you can do that, right? That is not very difficult to choose. If we choose A equal to 0, say C equal to 0, and this comes out to be 0, then we will choose G and B equal to 1. Yes or no? Is it okay? Yeah. Okay. So now it says it means the first one is wrong, and we will use this calculation for question option 2 and 3 even. See, A and B are diagonalizable over R, then M is diagonalizable over R. Now we will smartly choose here. Okay, let's put it 0 and it is 1. Okay, this is an upper triangular matrix with distinct eigenvalues, so it comes out to be diagonalizable. And we will choose E equal to 0 again and F equal to maybe whatever we need, but different from 0. Say, okay, whatever I will need here. So can we, this comes out to be 0, this entry is 0, this entry is 0 because we have choose. No, C is not chosen to be 0, right? Yeah, let's choose C also 0, right? This is 0, this is 0. E has to be chosen 0, this is 0, and take G is equal to 1 and B equal to 1 is already there, right? Yeah, do you understand? I am choosing two upper triangular diagonalizable matrices, but this commutator is not comes out to be diagonalizable. Again, I'm using the first calc because I have done this calculation. I will use this. Don't let it waste. Okay, so this is also wrong. And now it says that if A and B are diagonalizable over R, then there exists a lambda belongs to R such that M equal to lambda. The same thing will work here, because what I say that if you pick two in the last option 2, when I solve it for option 2, then we get here a non-zero entry, right? But this matrix can never be a scalar matrix. It says that the matrix is the commutator is scalar, because a scalar matrix is diagonalizable. On the other hand, a non-zero nilpotent matrix is never diagonalizable. Okay, so this is also not true, and this must be true. No need to make further calculation from the point of view of exam. Okay, so I have only made this calculation and solved the question completely. But many of you proceed in a way that, okay, let's take few examples, incorrect let's eliminate it, then we eliminate it, then we eliminate it. It is true or not, we don't know. First, many of you may try to solve it, then you would need more time. Do you understand? So how quickly we can solve the question? Okay, so now let me tell you that why fourth one is true. Okay, let's take it as an exercise. Okay, why fourth one is true. And if you don't know the answer, then what I said that at the end of this session, I will share a PDF. You will get that PDF. In that PDF, all the playlists, all the playlist link will be there where the complete solutions and detailed solutions are there. You can check that. Okay, if you directly want to see, before I send the PDF, just search in mathematics in the YouTube, and in the home page you will get all these things. Okay, all things are very organized and they are completely free. Okay, so you can watch them. That will definitely boost your preparation. Okay, let's solve this one. The question number 35. So yeah, what question number 35 says? Solution. So see how one solve it quickly also. Okay, let me not ask you. Okay, so let me give you 1 minute. Your time starts now. Try to solve it. Read it and solve it within 1 minute. Okay. Okay, very good. For solving, okay. I will check. Okay, so Tamaja, which one is correct?
Is 2.
2. Okay, maybe. Okay, right. Good. Okay, see student, how do you solve this question? Okay, see that m and r integer. From here, when you start reading the question, here you should observe that whenever m minus nc, this is just comes out to be, z to the power m minus n. But if m minus n is greater than or equal to 0, then this becomes an analytic function. And by Cauchy theorem, this integral comes out to be 0, right? Whenever m, it means whenever m is greater than or equal to n, the integral is 0. Okay, so it means this is not true, right? Because here m is greater than equal to n. So okay, where here also m is greater than equal to n, here also m is greater than equal to n, right? Because this thing is great, n plus 1 is greater than n, and n plus 2 is also greater than. It means these are incorrect. So don't worry about the question. Option 2, this is correct. No need to solve further. Do you understand? You don't need to make calculations. You just need to know about a theorem which says that when you integrate an analytic function, then the integral comes out to be 0. That's only thing you need to know. No need to make calculation. And this question can be solved within 1 minute, right? So this matters in the exam, okay? That what is your approach of solving questions? Okay, you have to be quick. But sometimes you try to solve quickly and make mistakes in the exam, okay? Don't do that also. Right. So, and this question, go and solve it. Raise your hand. Okay. So, Sri Sindhu,
Sir.
which one is correct?
Sir, I think option 3. Option 3.
Okay. Okay, fine. Option 3 is correct, right? So listen. So we said that group G has a property if every non-trivial homomorphism. Note that every non-trivial means the kernel cannot be the full group. Okay, students, the kernel cannot be the full group. From G to any group is injective. Which one of the following property? Which one of the following groups property A? See, if you see the question 3, option 3, I mean, you should not eliminate in the exam. You can directly solve it very quickly. So just look at all the 4 options at first glance, then you will realize that A5 is a simple group, right? Suppose that F is a group homomorphism from A to G. Since F is not identically 0, it means that, I mean, not the 0 trivial homomorphism, okay? Let's denote it by O. So it means kernel of F, only one normal subgroup is remained E, right? Because if A5 has only 2 normal subgroups, that means that F is injective. So the A5 has this property. No need for further investigations. Okay. Is it clear? Yeah. So you solve this question, okay? So I think I don't have that much time that I could cover all the questions. So let me solve the selected ones again. So solve these questions yourself, and if you are unable to solve, then watch the solutions at IISc Mathematics playlist. Okay. In the channel of IISc Mathematics, all the playlists are there. You can watch the detailed solution. Okay. So okay, let's solve this one. So it says that AN is a given sequence -1 to the power n, 1 plus 1 by e to the power n. Okay. And B is the max of A1 dot AN. And Cn is the minimum of A1 dot ANC. Let me write few terms. Okay. A1 is 1 plus 1 by E minus A2 is 1 plus 1 by E square. So can you tell me that this sequence is monotonically decreasing or monotonically increasing? This one.
Monotonically decreasing.
Okay. And decreases to 1. Right?
1.
The first term of this sequence will be the maximum, right? Yes or no? Okay. And so here, if you find B1 is max of A1. So this comes out to be A1, right? B2 is max of A1, A2. That is obviously A2, right? Because A2 is positive and A1 is negative, right? Now leave the odd terms because they are negative, right? Suppose that you are choosing the maximum of these, then the max of these is just forget about the odd terms, right? Choose the maximum from this. Yes or no? Yeah, because they are negative and these are positive. So A2 will dominate all. So dot A2 case, okay? I mean, this this subscript depend on n actually. So let me write it dot. So now what is the maximum? Let me know. What is the
A2.
maximum? Right. A2 is the maximum because you all told me this, right? That the first term of this sequence is the maximum. Right? No matter what n is. So it means the B1 sequence is this. A1, A2, A2, dot, dot, dot. This is the Bn sequence. Okay. Now, can you tell me that what is the sequence Cn? Now you have to choose the minimum.
A1.
A1, right. Because A1 is the minimum, right? This sequence monotonically increases to 1, right? Yeah. Okay. And by the similar reasoning and all, we get that the sequence Cn is A1, 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 dot, dot, dot. So now we can conclude, right? An does not converge. This is true because An has 2 limit points. If you consider the sequence of, even numbers, then you get, this A2 and A2n converts to 1 and A2n minus 1 converts to -1. So it has 2 limit points, so it cannot converge, right? This is true. And this is the limit supremum of An. Limit supremum of An is because we have only 2 limit points. Limit supremum is 1 and limit infimum is -1. But limit of Bn is a constant sequence. Its limit is A2. But A2 is not 1. Okay. A2 is not 1. So this option is incorrect, right? And the third says that limit infimum, which is -1, but the limit of Cn is A1. But A1 is not -1. So this is also incorrect. And this says that limit of Bn and limit of Cn is equal, but no, this is not true because A1 is not equal to A2, right? So yeah, this is one of the easy question in your exam and you must solve it. Okay, now can you solve this one? Now, this question also, it is from the CSIR NET 2024 exam, Assam. And this question also reminds you that you must solve the previous year questions from all the exams. Sometimes you see something, some theorems, some results in when you are solving the previous year question, then you use those results. And those results are sometimes helpful in your upcoming exams. In this question, one can use a result and solve it in a blink of an eye. Okay, try to solve this question. Oh, happy to see that many of you have raised the hand and solved it very quickly. Okay, very good. So, okay, Ria, which one is correct?
2 and 4.
4 and
2 and 4.
2 and 4. Okay. Okay, so Abhilipsa.
Sir, 1 and 4.
Okay. So yeah. Okay. Any other who wants to say the other options are correct? Otherwise, you can below your hand. Okay. If you don't have a different answer from Ria and Abhilipsa, then you can below your hand. So if you have a different answer, then just let me know.
Sir, 1 and 3.
HX. Okay, so let's see. Abhishek. Yeah, what is your answer? Okay, so first of all, note that take this as a, homework. G is a continuous function from closed interval 0, 1, 2 R and define the sequence of functions and such that G1 equal to 0. Okay, then define the function sequence of function fn x equal to x to the power n gx. Okay, then prove that this converts uniformly to 0. Okay, this is your homework. If you can't prove it after efforts, then you can watch the solution in ing mathematics channel. Okay, watch the solution. Well, let me tell you where you can watch. I think this kind of question is asked in some previous year of NET exam. Okay, so when you will explore all the playlist, then you will get somewhere it. In the real answers questions. Okay, I don't remember the exact address now. Okay, so
Sir, by Dinesh theorem,
Yes.
sir.
by what?
Sir, G has to be
Dinesh
continued.
theorem.
How by Dinesh theorem? Because we don't know that gx is what. Then how do you know that the function is fn is monotonic or not? Because g is a general
Sir.
function.
Yes, sir. Yes.
Yeah. Okay. So if
तो
you
सर
know about
fn
g,
x
then
निकाल लेंगे
Dinesh,
जो भी दिए होगा x power n
हाँ,
सर
लेकिन वो अलग अलग g पे डिपेंड करेगा, बट यू हैव टू प्रूव इट इन जनरल. ओके, मैंने बहुत सारी
Yes,
जगह पे फॉलो किया हुआ है IISc के क्वेश्चन पेपर्स पर, CSIR नेट के, तो आप लोग प्रूफ देख सकते हैं. ओके, अदरवाइज प्लीज कीप दिस रिजल्ट इन माइंड. आई हैव सीन too many questions. In GATE, in NET, in NBHM, CSR, everywhere this result is used. Okay, and using this you will solve the questions very quickly. Otherwise you will feel difficulties. Okay, I'm not saying that you will not be able to solve without using this one, but this will save a lot of time of you. Okay, maybe 5 minutes sometimes. Okay, so see solution.
So one thing, in the
Yeah,
homework you
please.
gave that G has to be continuous.
Yeah, I said continuous.
Okay.
Okay, but I forgot to write. Thank you. Let me write it here. C01. Okay, thanks. So G is an maximal ideal of C01. Okay, hope you understand. So all those functions which vanishes at one are forms a maximal ideal, right? Yeah. Okay. So see. By the way, if G does not belong, if some function does not belong to that ideal, then this sequence is not uniformly continuous. Okay. So see, now you have G is a Gx is here continuous, right? Obviously continuous, being composition of two continuous functions. Then G of 1 is 0. right? Yes or no? So why above result? What I wrote, x and gx converts uniformly. Okay, right? Everyone understands that the first one is true. So the second one cannot be true. Now let's check about this. So limit x n tending to infinity comes out to be, can you tell me what this comes out to be? Because this should be a constant, so this comes out to be 0 if x belongs to this, and I think 1x is equal to 1, then this comes out to be 1. What do you think? Is it correct? Yeah, so
Yes, sir.
here you have to use the another result, which says that the uniform limit of continuous functions is continuous, right? But this is not a continuous function. So it means the x and hx does not converge uniformly. And I mean, you have solved this question very easily, right? So this one is true. And please be careful solving such easy questions, okay? Sometimes you think that the question is easy and you made mistakes, very silly mistakes. And when you come to home and you regret about it, oh, I made this mistake. And if I had not made those mistakes, I would have qualified the exam with very good marks, right? Many times it happens to the students, okay? So be careful whenever you solve an easy question. I mean, be aware. Okay, solve with be meticulous whenever you are writing in your rough papers. I mean, sometimes हिच पिच हो जाता है तो फिर गलत भी हो जाता है. Okay, so चलो. Okay, so let's solve this one. Okay, how many questions? I have now 4 questions. So let's solve, and the time. Okay, I have 7 minutes. Let's solve these questions quickly. Okay, which. Okay, give me 1 minute and solve this question yourself first. Okay. I expect that you answer this. So, yeah, this question must also be solved very quickly. Okay. So, the first one, there exists a 5 cross 5 real matrix whose minimal polynomial is this. Okay. So, first take a matrix with minimal polynomial x cube 0 1 1 1 0 0 0 0 0, right? Its minimal polynomial is 1. And then consider a matrix with minimal polynomial x square plus x plus 1. That is easy, right? Let me write ABCD here. You can do that. Okay. Now consider this 5 cross 5 matrix. So its minimal polynomial is LCM of the minimal polynomial of this and this. This comes out to be this one. Very easy, right? And see, the second is not true because every real matrix of odd order has a real root, has a real eigenvalue, right? So it has all complex eigenvalues, so it cannot be true, right? So now I should ask you that, and the same thing, whose minimal polynomial is this? I mean, why these options are same? Oh, this says the real matrix. Okay, this says that the complex matrix. So complex matrix can exist, right? Or not? Okay, so let's solve it later. So first try to solve this one. So there exists a complex matrix whose minimal polynomial is this. So what do you think? Okay, let me know the example. So let me tell you a result. Okay, do you know about the companion matrix? How many of you know about the companion matrix? I mean, you can make the example, but how to solve such exams, such questions easily in the exam? So you can use companion matrix. For a companion matrix, there is some result about minimal polynomial and characteristic polynomial. Can anyone of you let me know about that? There is a result.
Both.
Batao. Someone spoke.
So the characteristic and minimal polynomial are same.
Okay, who said that? I mean, can you say once again?
Sir, they.
Very good. Okay, so CAX and MAX is equal. Okay, right? Okay, so and it's not difficult to find a. I mean, suppose you have a given a polynomial, then there is a matrix whose characteristic polynomial is this. That is called companion matrix. Okay, I'm not going to write that 0, 1, 0, 0, 0, 0, 1 like this, and here the coefficient minus A0 minus A1, right? Do you know about that? Minus A minus 1. So I have told this for any general polynomial. Okay, suppose you have given a general polynomial, then there is a matrix with that characteristic polynomial, and the minimal polynomial for that matrix is the same as characteristic polynomial. So this is also true. Okay, you have a companion matrix with this minimal polynomial. Now, what about the fourth one? So you should tell me now.
It is true, right?
Why it is true?
So there is a 4x4 matrix, and we
Yeah.
will take it as one block, and the last entry we will take a root of this polynomial.
Yeah, very good. So there is a 4x4 matrix. Very good. So with that minimal polynomial, and here we'll take omega. Omega is the root of that, right? The minimal polynomial of this is x square plus x plus 1 whole square. We will take the companion matrix with this characteristic polynomial, and here we will put the omega. When we will take the LCM, then the LCM would be this, right? And we are done. I mean, this is also possible. So in this way, you should solve the questions. Okay. Many of you try the examples in different ways. I mean, there may be other ways which are easier than it, but this is one of the way. Okay.
So can
Any
you please tell why the second one is wrong?
Why one is wrong?
Second one. Why the second one is wrong?
Because it
Second
says that there exists a 5x5 real matrix. Okay. And every eigenvalue of minimal polynomial, every root of minimal polynomial is an eigenvalue. Rather, every eigenvalue is a root of minimal polynomial. Do you know that?
Yes, sir.
Yeah. But a real matrix of odd order always has at least one real eigenvalue, but it has no real roots.
Okay. Got it.
Yeah. Okay. So, okay. So let's solve these questions quickly. Okay. I'm running out of time. So, which one of the following rings are integral domains? The ring of polynomials in 3 variables over R. This is very true, right? R, X, Y, Z. This is true, right? So the ring of complex analytic function, it uses the identity theorem and continuity of the analytic functions, and this also forms the integral domain. Okay. And the ring of 2x2 matrices, this is not, because you can take this one, okay, multiply, and you get the 0, 0. So that has 0 dividers. This is not the ring of continuous function, and it is very easy to make such examples. I mean, put it 0 here, x minus 2, when x belongs to 0, 1 by 2, and when x belongs to 1 by 2 to 1. And for the other function, you can just switch. Okay, here x minus 2, here 0, and take the product of these two. These two are the continuous functions. Okay, because at 1 by 2, right hand, left hand, and functional values all are equal. Okay, if you take the product, this comes out to be 0, and these are non-zero functions. So this is not an integral domain, and these two are integral domain. Okay, you must have seen this. I'm not going to prove because I don't have that much time now. And okay, so this is very easy also, that f is an entire function, and this u plus v, and u and v satisfy this, right? So it means that the image of function looks like this. U plus v equal to 1 means this, right? So the image is not dense, but the image of our entire function is dense. That's why f is a constant function. Okay, only constant entire function has non-dense image. Otherwise, the non-constant entire functions has dense image. Now you can, conclude which one is true and which one is not true. Okay. By the way, this is always true. FC is connected for any continuous function because entire functions are continuous. So this one is true. Okay. So I think now you can do. Okay. So let me solve this one very quickly. Okay. And one thing I want to let you know that in the abstract algebra portion, every time, it is very easy to solve question in the exam. If you have worked hard enough at home, okay, solving questions of abstract algebra is very easy because all you need to know the results, theorems, and all, and you apply them and you get the results. Exam results, I mean to say. Okay. So which one of the following quotient rings are filled? So this is a PID and this is a non-irreducible polynomial, right? Means that non-maximal ideal. Oh, sorry. This is an irreducible polynomial. Sorry, irreducible polynomial. Irreducible polynomial because it is the 7th cyclotomic polynomial. So it is maximal ideal. It generates maximal ideal, and quotienting by the maximal ideal ring gives you the field. So this is a field, and this is not the irreducible element. This is reducible. Okay. So do you know that
-1 is the root.
-1 is the root. Sabas. So this is not a field, and this is obviously isomorphic to Z. So this is not a field, and this is, so by Einstein criterion, this is irreducible, right? I hope you know the Einstein criterion. You take the prime 41. Okay, and this is again irreducible polynomial, and quotient. This is a maximal ideal, and quotienting by maximal ideal gives you the field. Okay, so I will stop here. If you have any question, any quick question, then please feel free to ask.
So in Z41, it is reducible.
कौन सा वाला? फोर्थ वाला reducible कैसे है?
In Z41.
So let it be. Then what happens if it is reducible in Z41? Then
we can take Z3.
You have polynomials which are reducible modulo. There is a polynomial x to the power 4 plus something which is reducible modulo every p, but that is irreducible in Q. So there are polynomials which are reducible, which may be reducible when you reduce to ZP. So that doesn't mean that those will be reducible. Okay. So it is irreducible by Einstein criterion. Take the prime 41 and apply the Einstein criterion. Okay. Okay, so let me stop the recording. So you don't have any questions, right? All? Okay. Okay, so it was nice experience to teach you all for 2 days. Okay, so let's meet in other sessions. Okay, bye-bye.